Well, howdy, physics sleuths, and welcome again to yet another lecture of dynamic gravity. So, I am not perfect, and neither is dynamic gravity yet, but I'm working on it. But I can assure you, it's pretty damn close. But there are some mistakes. Like, for instance, God sent me a nod last night, and he told me to think again on entanglement. So I did. And probably because now I have the luxury of being able to look back to see how everything fits together neatly. I can see where the errors and flaws are much easier. And of course, I have realized that I believe now that my explanation on what is going on with entangled particles is not quite right. It's close, but there is one major difference that makes the world a difference. And that difference is whether or not you violate Pauli's exclusion principle. Now, I didn't want to violate it before, but I didn't see any other way not to. And to be perfectly honest, the standard model has completely crumbled in my wake of destruction and chaos and mayhem that I've left in the world of physics with dynamic gravity. So I'm not really too into it if they say something has to be this way or that way, if they can't prove it. Sorry. I'm just not convinced. But I do believe that I got it wrong. And so now this video is an official issued correction to what is going on with quantum entangled particles that are both sharing the same orbital position and what is going on there. Okay, so that's what we're going to do. It's going to be great. I have no doubt. All right. So, this is not entanglement. It's something else. None of your business. Nope, definitely not. Okay, here we go. Quantum entanglement. Okay. Quantum entanglement is a phenomenon where the quantum state of each particle cannot be described independently in the state of others, which particles separate by large distance, topic entanglement, blah, 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 blah. So, what these guys are talking about is they're talking about the fact that once you entangle two particles, when you separate them, you can tell which one is up and which one is down, no matter how far apart they are or what's going on, as long as you don't destroy the state. And they believe currently in physics that this is magic. This is straight up fucking pixie dust that a fairy farted out, snapped their fingers, and decreed it so, and just magically happens. They don't understand what the fuck is going on with particles. They don't know. But in case you haven't figured it out, I kind of do, and I kind of showed you the game. One electron, a second electron, same orbital. Oh, God, how the fuck is this gonna fit in there? Oh, that's the only way. That's the only way it will fit in the same orbital. One up, one down. And then when you separate them, guess what? This one's still down, and this one's still up spin. That's how it works. Until they get entangled with something else, and it fucks it up. That's what's going on. It's that fucking simple. But nobody gets it. So, let's dig deeper, alright? Okay. So we got our Bohr model, okay? Now, this means that the electrons have orbitals, okay, around the atom. You know, all these electrons, blah, 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 all these electron orbital states is what I'm really looking for, okay? And maybe a model of an atom wouldn't be too shabby as well. Maybe this one. Yeah, This is not so bad. I can deal with this. Okay? So, we have an atom, okay? And it has so many protons. And for every proton that's positive, it wants to have an electron to counter that. So you got 3 protons, you got 3 electrons. See that? In every proton, you got to have a neutron if you want to stick 2 protons together. Explains the whole architecture and everything of the atom. So simple. It's really not that complicated. All right? Now, the way that these fields work, because think of these particles are like little magnetic magnets, okay? When you have a magnet that's oriented in a certain way, you're going to have a magnetic field oriented in a certain way. And anything that comes in that magnetic field is going to be oriented in a certain way based upon how the field is oriented, based upon how the magnet is oriented. So simple. Okay? So, you get these states where electrons tend to hang out. Depending on the nucleus and how the orientation of the magnets of all the protons are aligned. And these are called atomic orbitals. Okay? Simple, right? And they look different for every atom has completely different orbitals and blah blah blah. This is like the orbitals for hydrogen, and you can see, dude, you start adding more and more electrons, and the electrons just start moving around into where they tend to find equilibrium and they hang out, right? So they have these states, and if you have enough, they will have orbitals where they can become entangled, right? Or orbitals where, orbitals where 2 electrons will share the same orbital, okay? You will have, but they can only do this if they switch the orientation of their spin states, so that one spin up and one is spin down. That's because, also think about it, if one is spin up, it's going to want to constantly travel up, okay? And if the other is spin down, it's going to want to constantly travel down because of what electrons are, or any particle, and when they're basically vortexes is what they are. It's a fact. And then as they spin, they propagate, and that's what gives them their thrust, their momentum. So the fact that the particle is able to keep itself together is what also makes it want to go at the speed of light. That's how it works. Okay. So the spin determines what direction the particle wants to go, or vice versa, you could argue. All right. Now, all the different orbitals, blah 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 blah. Here we go. Here are some orbitals I want to say. Since it's a subshell, anyways. Where the hell are the orbitals at? Here we go. Here's some orbitals. 1s, 2s. These are orbitals. I wish I could see a better picture of it. Fuck it, man. Fuck it. I think I'm just gonna do a new search for this, because I really want to show you. Yeah, who cares? Okay. So here we go. All right, here's like the orbitals, right? We got level 1, just 1. Level 2, you got 1 up, 1 down, blah blah blah. Vice versa. Here's a really good one. You see hydrogen, helium, all the orbitals, 1 spin ups, 1 spin down, depending on how many are there in the orbital states, and that's how they tend to fill out. They first fill out an orbital, and to do that, they have to conserve energy and basically become stable. They have to find equilibrium amongst themselves, is what has to happen for 2 electrons to share the same orbital. Once again, they just basically, they're like this when they meet, and then for whatever reason, one's more dominant than the other, and the other one's like, okay, I'll go down. You're up, I'm down. And then that's how they share the same orbital. Okay? Very simple. That's what's happening in quantum entanglement. Okay? That's all it is. Now, because of this, you get things that happen. Okay? Because we have to remember, according to dynamic gravity, now general relativity has no clue what particles are. They're fucking retarded, and they don't want to know. They just think they're fine with their framework of, mathematical construct that takes Newton's math and adds a time dilation to it, and they just think that's all that needs to ever happen. They don't care about anything else. But what happens is particles are essentially vortexes, okay? Vortexes like this, okay? So they're in the shape of like a donut, which is called a torus, okay? And they're constantly spinning, and that spinning motion is what also gives them the momentum to go forward. I don't know the exact mechanics of that. I'm not going to pretend I do. I don't. It's definitely, I can give you the overall general synopsis of what's going on, but as far as the exact mechanic, I don't think I can. And I believe this is one of those limits I'm just not going to be able to do in my lifetime. We need to know more about the actual spin of electrons to really formulate how that is creating the momentum and keeping the electron together and everything. We're just not there yet. I don't want to guess. All right. Believe it or not, everything that I put forth in dynamic gravity, I honestly believe that is a deal, and I show my evidence on how I got there. I show my math. Okay. And that's the deal, okay? So, particles are vortexes, all right? And vortexes, if they move, can create more vortexes. It's a fact. It's called the Biot-Savart law, okay? And that law governs the generation of vortexes and also, like, electrons and magnetic fields and blah, blah, blah. Same thing. So what do you think about that, all right? So, we have a vortex, okay? These are vortexes. And they will share the same orbital, okay? So you'll have like one electron here and one electron here. And they will be like this. One up, one down, okay? That's the deal. Now, if an electron gets hit by another electron, whether you believe it is just momentum that's bumping it, or whether it's actually absorbing that electron, like I believe, in changing the charge, which then finds redistribute in equilibrium or whatever. If a photon comes in and gets absorbed by one of these entangled electrons, it's going to hit the one that's on the outer first, which is going to be the up. Okay, it's for our standard. We're going to designate the up. So that electron is going to absorb a photon, and then it's going to change its equilibrium, and it's going to have to relocate, move, and have all this jarring motion. It's going to back and forth. It creates a secondary photon that's emitted out. So it absorbs the primary, and as it's absorbing it, it's emitting the secondary as it's going through the field of the proton, right? And that's how a photon is created. Photons are basically, electrons are the highest energy form of a photon, okay? It's a fact. If you look at quantum mechanics, it says the wavelength of an electron, what they've measured, is literally just a hair under of what the shortest photon we know of, like a high energy gamma photon. And that's because if it gets any shorter, it's now an electron. It's a fact. That's what happens. Electrons and photons, same fucking thing. But modern scientists have no clue because they're stupid as fuck. Okay? So, you have an entangled pair. Okay? The one that's up, let's say, is the one that's on the outer. It's going to be the one absorbing the photon that's going to be reacting. And it's going to go closer to the nucleus, not further away. Closer, and then it's going to bleed off that energy immediately and then go back. And how long the photon hits it depends how long it takes for this process to happen, which determines how long the wavelength of the photon is that gets emitted, which is why it emits always the same wavelength of light that it absorbs, unless you have some weird funny shit going on like splitters or wave combiners. These materials exist, but I haven't looked into what's going on there. They might have some clue. I don't know. I haven't even looked at it yet. Maybe I will one day. We'll see. Okay. So, that entangled up photon will release a photon. My bad. That electron is going to release the photon, but it's going to be going from the up spin, okay? So the up spin determines whether it's going to be left chirality or right chirality, okay? A left-handed particle or a right-handed particle. And if you have, say, an energy that comes by whatever reason and hits the other photon, because it's like a right-handed photon, then only that one moves. And now the photon that's released is not a left-handed photon, but a right-handed photon, okay? Do you see now how we can get both left-handed photons and right-handed photons and electrons too, because everything, it's all vortexes that can create themselves depending on how much energy is thrown into it, okay? So we have the ability to generate left-handed and right-handed photons and particles, okay? And we know that like all particles are left-handed and right-handed. The only one that they can't really find is the neutrino, which I have a reason for that, because neutrinos are the exact opposite of electrons. So these are electrons. Neutrinos are created. They are like an electron that is positive, that is created by the nucleus when it undergoes a radical shift, okay? When it has like a fusion or fission process it undergoes, the nucleus will shift, and that shifting will create the back and forth motion of the particles that generates the protonics force variant of an electron, which is a neutrino. But because the orientation of the atom can only be one way, an atom has a top and a bottom, if you want to say it, and when it shifts, it's going to shift this way, you only get one type of neutrino, left-handed neutrinos, okay? You don't get the right-handed type. Now, it is possible to do that, to get other type of neutrinos, I believe, but it happens under very specific and extreme circumstances. But typically you don't get left-handed or right-handed neutrinos, and that's why. Because the atom has an orientation, and when it shifts, it creates the neutrino based upon the orientation of the atom, which is always up. That's the way it works. Truth. All right? So, we can now make left-handed and right-handed particles. It's called chirality. It's when you left hand, right hand. Exact same thing. It's just exact opposites. Okay? It's called chiral partners. Left chiral partner, right chiral partner, or vice versa, which however you want to go it. Okay? So, yeah, and they have different reasons to explain why this is, and they're all bullshit, and they're wrong, and they don't know anything because they're stupid, and you shouldn't listen to them, and you should listen to me. Sad but true. But, yeah, every particle, electrons, quarks, photons, they all have left-handed and right-handed versions, and that is because every particle can have a quantum entanglement, like I said, where they both share the same orbital or position, and the only way they can do that is that when they touch, when they come together, one's up, one's down. I'm going to explain it. I'm going to draw everything. Just give me a minute. We're working there slowly but surely. I'm trying to get there, okay? So that's what's going on, okay? Now, not only does this explain how left-handed and right-handed chiral particles are, created, or whatever, but it also explains antimatter. Because if you have an high enough energy particle, like a high energy gamma photon, okay, and it hits an entangled pair of electrons, all right, now not one of them is going to go. Okay, so it's not like boom, boom, you're going to create either a left or right-handed photon or electron, depending on how much energy and how fast the reaction happens. But if you get hit by a high enough particle that both move, okay, and when that happens, one is going to go with its momentum, meaning it's going to shit out a particle, an electron, if we're talking about electrons, or a quark, if we're talking about quarks, okay? It's going to shit out that. The other one that's the opposite spin is going to go against its momentum. And that's the very definition of the math that we have in physics anyways for current, which explains how negative antimatter particles are created. You now have a particle that is identical to an electron in every way except the current is 180% back the other direction. And this is why when they touch, they nullify each other, because they both have currents going the exact opposite momentum. They counteract each other and they nullify each other and then turn into high energy gamma waves. They do because gamma waves and electrons are essentially the same thing. Remember, that's a fact. I taught you that many years ago. If you didn't get the memo, you're getting it now. It's a fact. Okay? So, what we've got. Now, this is how we create antimatter, because we're going to have an electron. If we have an entangled pair of electrons and we hit it with enough energy and the gamma photon, whatever, makes both pairs go inside the field of the proton, you're going to have, because vortexes make vortexes, if you have enough resistance, whatever, you're going to have an electron shit out and you're going to have the positron shit out, because the one that's going against momentum is dragged against momentum, it has a negative current, is the very definition of a positron. Okay, and this works for quarks, works for neutrinos, works for all particles if they can have an entangled state where they're both sharing the same space, an orbital or position, something like that. Okay. So, we've explained how entanglement is important, how it is the inevitability of conservation of energy within the atom to have the lowest energy state, and that this is the reason why we have left-handed and right-handed particles, and it's also the reason why we have matter and antimatter. Okay? Now, this is all old news. I discovered this all years ago, and I wrote a paper on it, published it, and to this day, maybe 100 people have read it and nobody gives a shit. But it's there. I have it in my description of this video, and all my videos, if you want, link to it in the archive. Okay? It's a fact. And I'm going to write another paper because I just figured out all the nitty-gritties of neutrino oscillation. So I'm writing that paper right now. Hopefully that will be published in the next week or two. And my next video will be completing neutrino oscillations. Last week was a mess. I know I had to do the data dump because it was too much. My brain was fucking running in circles and not functioning. Now that I cleared it all out, I was able to see the way. It's done 100%. I think 99% is one thing I have to figure out. So that's going to be great. I'm going to completely 100% finish off and tap out neutrino oscillations next week or two. Last week was just a warm-up, and you saw how fucking intense and crazy shit that was. Yeah, that's a deal. Okay? Now, so the correction is, oh, and look at that. They say antimatter is just made by when you have energy and collision, so an explosion. If you just have a stick of dynamite go off, you're making antimatter. Maybe a little bit of antimatter. And if you have a big explosion of antimatter or dynamite go off, you make more antimatter. That's all they're saying. They're stupid. They don't fucking know. Don't listen to these people. They're stupid. Listen to me. I don't lie to you. If I don't know, I tell you I don't fucking know. And if I know, I make it pretty fucking obvious, no? Alright. So, here is where the correction is, okay? The way that I have described entanglement before is we will have an atom, right? Of like beep 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 bop, boop boop beep 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 bop, boop boop beep 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 bop. And it will have, let's say, 6, right? So we'll have, this will be a neutron, beep bop, and this will be a neutron, beep bop. This will be a neutron, beep bop, and this will be a proton. I know I suck at drawing, dude. I was never a good artist. Okay, but you got it. It's 3 protons and 3 neutrons, all right? So we're going to have 3 electrons, all right? We're going to have an electron over here by himself because he's a loser. And we're going to have 2 electrons over here that want to share the same orbital, which is, let's say, right here. Okay, let's say these are the orbitals right here. Okay, these two electrons want to share the same orbital. So, the way that I previously explained this is I said, okay, electrons are vortexes, so we have a vortex, okay? Beep, beep, bop. That, okay? It's like a donut. It's called a torus, I found out, actually. It's the official. And they're multiple, they're tori. Who knew? And if we look at it at the side, it's going to look more like this, okay? Beep, bop, bop. Now, it's going to be spinning a direction, okay? And let's say we got two of them. Beep, bop, bop, boop, boop, beep. Okay. Say this one is spinning this way, beep, bop, up, and this one is spinning down, beep, bop, because we know one has to be up and down for them to share the same orbital, okay? So this one will be spinning this way, beep, bop, excuse me, and this one will be spinning this way. So the exact same particle, they're just opposite spins, okay? Now, what happens if you take these two particles, let's say you vivisection this right here, okay? You go vivisection that. What you get now is we get the particle, okay? We get the spins, okay? And it's linked here by the particle, but essentially what we see is we're going to see it's going to be spinning in a circle, okay? Either it's going to be going this way or the other way, okay? If it's spinning this way, it's going from the inside out, so this one will be going this way, okay? So, if we have another particle here together, beep, boop, boop, beep, pop, and this one's going the opposite direction, okay? It's not going to be spinning the same way. And so this one's going from the inside to the out. This one's going to be going from the outside to the in. So it's going to be going this way. Beep, beep, pop. Beep, beep, pop. Okay? And if you can notice, if we bring these two together, they're both spinning opposite directions, right? So when they touch, they're not going to want to merge, okay? But if you put enough force, because you got an atom saying, fuck you, conserve energy, then it would theoretically, I thought, be possible to merge the two simply because these two vortexes of the atom, of the electron, or quark, whatever molecule you want to do, are going to be spinning the same way when you overlap them, okay? Which means that theoretically you could stack them on top of each other and the energy would be going the same way, even though the spin would be going the same way, even though the momentums would be going the opposite because of just how things played out. Which now satisfies every rule that I need to be true for my theory of entanglement to go forward. Except for one, the Pauli exclusion principle, which says that you cannot have like two electrons in the exact same spot because they're two separate particles and they will not merge. And I'm saying yes, they are merging, but only if the energy goes in the right direction. I was never happy about that, but it did explain everything, so I didn't doubt it too much. God told me to doubt it, so I did. And now I've found a different way, okay? So, I don't believe this is what's going on anymore. Just because this is the harder way that violates more laws to make it happen, okay? So, what I believe is going on now is we got like an electron, right? Beep, pop, pop, boop, beep, beep, pop. Okay? And there's another electron, okay? And they want to share this same orbital, all right? They both want to be here. Now, what they're going to do is they're going to stack like this, okay? But eventually, one is going to become the outer electron that envelops the inner electron. Okay? So you got this hole, there's a vortex, right? Vortexes have a little hole in the middle. It's the way they operate. That's where the electron goes. So let's make this the inner electron, and then we'll have an outer electron that will be touching it, essentially, boop, boop, that will be spinning the other way. So this one will be spinning this way, doot, doot. And so this one will have to be spinning this way. Because what happens when you have gears, okay? When this one spins clockwise, this one is going to by default spin counterclockwise because they're touching and it's transferring energy and momentum to the other one, which now gives it the direction it has to go because it's all from the same energy source essentially. Okay. Now technically these are not the same energy source. That's not an exact one-for-one comparison, but it can be said one will be more dominant than the other for whatever reason because it's, you know, closer or further away from the nucleus of the atom, however that interplay works. And it is going to now take on the dominant position, which would probably be the outer ring, I'd assume. Maybe the inner ring, because that would probably be more concentrated. Maybe the inner ring's the dominant position. It's hard to say. Atoms are so fucking weird. Okay? So, we got one that will be spinning down, and then we have another electron which will be, you know, surrounding this like concentric rings that will be spinning the other direction, because as this one spins down or clockwise, the one that it touches, and they're going to touch because they're sharing the same orbital, there's not that much room for them to work with. I mean, they're kind of cramped. It's going to force the other one to spin the opposite direction. Okay? Now, this this does leave a problem that the momentums would now not completely cancel each other out. But you could also do a variant of this. Like I said, I'm not 100% certain how. I don't have a camera. I haven't taken pictures of this shit. It's all mental framework, okay? You could do the stacking variant, okay? Where I'm pretty sure. Where if this one, let's say you got two that stack. Okay, so it's no longer concentric, okay? Because we got concentric rings. Alright, so concentric rings is like a ring inside of a ring, okay? That's what I'm thinking this is, but now that I'm digging into it deeper, I just said it last night, I'm still figuring this out. Maybe it's better if we do the stacking variant, because now this one, let's say, is going to be doing upspin, okay? The top one's upspin, and the bottom one is bottom spin, okay? Because they're touching, and this one's spinning this way, so this one has to spin the opposite direction. But because they're spinning, they still want to go forward because momentum, they want to travel at the speed of light. The only reason they don't is because something's stopping them. They're locked in an orbital. So they still have that momentum. So to counteract the momentum, otherwise the atom's going to be destroyed apart by electrons wanting to travel at the speed of light, just going in that direction they're facing. Now you have two torus, vortexes, electrons, donuts, whatever you want to fucking call it. This one's has a downspin, wants to go down. This one has an upspin, wants to go up. Now they're counterbalancing each other out perfectly, and they just stay still. And the system is now in perfect equilibrium and stasis, where the atom does not destroy itself and fall itself apart, which is what we would expect to happen due to the conservation of energy. The one law in all of physics that we know always applies. Everything in this fucking universe is lazy and is always going to take the path of least resistance. Everything. Human, particles, photons, energy, stars, planets, fucking animals, everything. Conservation of energy, the one rule that always proves true. The universe is lazy as fuck. It's a fact, okay? So, that's all I wanted to do, was to issue an official correction today on how entanglement works according to dynamic gravity. Okay? I used to think it was like this because that was the first way I found to make it work. But I knew it wasn't perfect, and now that I've completed much more of the picture and the puzzle, I can easily go back and retcon things in a way that makes them more conducive with the laws of conservation of energy, which is what we ultimately want. And this one, the stacking version, is probably the absolute best one that adheres to everything. Pauli's exclusion principle, conservation of energy, momentum, blah, 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 everything. It's got everything. This is probably the answer, is you have two electrons in the shape of donuts, tori's, that are stacked upon each other in an orbital, just like this, okay? This is the way. It's probably not like this because it would violate Pauli's exclusion principle, and it's probably not like this, concentric rings, because that would violate momentum of energy, not conservation of your momentum, okay? This one doesn't violate any, so it's probably true, but I've been wrong before, and I'm sure I'll be wrong again. But this is only the second correction I've had to issue in the last 4 years of dynamic gravity. So this is a rare day. Relish it if you're a hater of dynamic gravity. This is one of the few days I have to actually, say yes, there's a problem and I have to address it. Everything else always works out perfectly. Something you might want to think about. I'm just saying. So, that is the deal. I think that nips that up in the butt pretty neatly and solidifies my current thoughts and beliefs on the matter of entanglement and how the particles are actually physically holding themselves together in the orbital and what's going on and everything, okay? Minor change, but I believe it has to happen because I don't want to violate Pauli's exclusion principle unless I damn sure have to, and I don't have to, as it turns out. I thought I did, I don't. Yay! So, next week, I'm going to try and drop my totality of the neutrino oscillations and explain to you particle by particle, bit by bit, everything that's going on and the entire way on all particles. It's going to be a real fucking doozy, a rager. Make sure you bring lots of drugs to stay in the game on that one, or you're not going to be able to keep up. I'm sorry. And on that, I bid you adieu and farewell until next Wednesday. Adios, muchachos. Bye.
Like, subscribe, submit.